In example 1, we are finding the infinite limits, limits at infinity, and asymptotes of the function. So when you look at your graph, you want to look for wherever there would be asymptotes. Let's look for vertical asymptotes first. It looks like there's a vertical asymptote at -1. There's a vertical asymptote at 2. Now that we know limits, we can prove that there's asymptotes by showing that the limit at -1 and the limit at 2 equals infinity. So we have the limit as x approaches -1 is positive infinity, which tells us that there's a vertical asymptote at -1. We also have the limit as x approaches 2 from the left is negative infinity, and the limit as x approaches 2 from the right is positive infinity, so there is a vertical asymptote at positive 2. When you're looking for horizontal asymptotes, we see there's a horizontal asymptote at positive 2 and a horizontal asymptote at positive 4. And that is because the limit as we approach negative infinity equals 2, and the limit as we approach positive infinity is 4. So this is how we would write this information. If we look at the far left of the graph, we're approaching negative infinity and we got a limit of 2. So that tells us that y equals 2 is a horizontal asymptote. When we look to the far right of the graph, we're looking at positive infinity and it levels off at y equals 4. So that's the limit, and that tells us that there's a horizontal asymptote at y equals 4. When you find your limit at -1, we see that it equals infinity. So that means there is a vertical asymptote at x equals -1. When we looked at 2, we see it goes to negative infinity on the left, positive infinity on the right, both of which tell me that there is a horizontal asymptote at x equals 2. So this is how you would solve the problem. This is what you would write. In example 2, we looked at this last year. When you plug in infinity into the denominator, whether it's positive or negative, you end up getting 0 in these cases. So 1 divided by a huge number like infinity is going to be so small that you're basically going to have nothing left, so 0. Same thing here. 1 divided by a negative huge number, you're going to make 1 so small that it's basically 0. So anytime you divide by infinity, you get 0. If we were to plug infinity in here in example 3, we're going to end up getting infinity divided by infinity, which is not a defined answer. We don't know what infinity divided by infinity is. So what we have to do is create fractions out of each term so that we can take some limits to 0, and whatever is left over will give us the final answer. So write this down and let's do it together. The technique for solving something like this is to look for your largest variable on the bottom, which is x squared, and divide by it. So we're going to divide by x squared in the bottom. So whatever we do to the bottom, we're also going to do to the top. We're going to divide everything by x squared. So rewrite your problem. We now have 3x squared over x squared, negative x over x squared, negative 2 over x squared. On the bottom, 5x squared over x squared, 4x over x squared, and 1 over x squared. Then you go through and reduce each of your fractions. So your x squareds reduce, this x cancels, your x squareds reduce, this x cancels, and whatever's left, you can go ahead and plug in infinity. So we're going to have 3 minus, this is a 1 over x, so we're going to plug infinity in there, minus 2 over x squared, so if you plug in infinity, it's 2 over infinity squared. This is just 5, plus, this is 4 over x, so if we plug in infinity, it would be 4 over infinity, plus 1 over x squared. If you plug in infinity, you're going to have 1 over infinity squared. And what we just saw is anytime you have a number divided by infinity, it ends up going to 0. So this is 0, 0, 0, 0. So we have 3 minus 0, which is 3, 5 plus 0, which is 5. So the limit is 3/5. Example 4, find horizontal and vertical asymptotes for the graph of this function. To find your vertical asymptote, so let's start there, we're going to set the bottom equal to 0. because if the bottom equals 0, it's undefined at that x value, and it will create an asymptote at that x value. So if we set the denominator equal to 0, we're going to get positive 5/3. And so we already know that that is where our vertical asymptote is. We just need to prove it using limits. So let's do that now. So if we are trying to prove that the vertical asymptote is at 5/3, you need to show the limit to the left of 5/3 and the limit to the right of 5/3. So what we do is when we plug in 5/3 using direct substitution, we know we get 0 in the bottom. If we know we get 0 in the bottom, so something over 0, we know it's going to be infinity. Same thing when you plug in positive, or from the right. You're still going to get a number over 0, which we know is infinity. All we have to do, we can go ahead and write infinity down, is we have to plug in a number to the left and to the right and decide whether it's positive or negative. So if you plug a number in to the left of 5/3, so for example, try plugging in the number 1, you're going to get square root of 3, which is positive, over -2, which is negative. So you end up getting a positive divided by a negative, which means you get negative infinity. If you plug in something to the right of 5/3, for example, positive 2, you're going to get a positive over 6 minus 5, which is another positive, and a positive divided by a positive is positive infinity. So you get positive infinity. So you just need to show that the limit at these x values was infinity, and that is enough to show that there is a vertical asymptote at x equals 5/3. Now, we're going to look for our horizontal asymptotes. To find your horizontal asymptotes, we need to find the limit at negative infinity and the limit at positive infinity. This is always how you find your horizontal asymptotes. In both cases, if you plug in infinity, you're going to get infinity divided by infinity, which we said earlier doesn't have an answer. So you need to find the variable in the denominator and divide by it. So we're going to divide by x, or multiply by 1 over x. If we do that to the bottom, we have to do that to the top. Now the problem with the top is that there's a radical on the numerator, and you can't move an x into a radical unless it has a matching radical. So what we're going to do is put a radical on the 1 over x. Now if I put a square root on 1 over x, I've now changed the factor. These are not equivalent. So you need to take your 1 over x and square the inside so that you're undoing the radical you just added to the problem. So now that will look like the following. The limit of, well, I don't want an equal sign, square root of 2x over x squared plus 1 over x squared. And on the bottom, we still just have an x. So 3x over x minus 5 over x. And reduce your fractions. So we have square root of 2 over x plus 1 over x squared over 3 minus 5 over x. So that's fully reduced. And now we want to plug in our negative infinity. So whenever you have a square root and a negative infinity, there's one more thing you have to think about. Is when you're plugging in negative infinity up here, this is a negative number. So when I multiply by 1 over x, right here, I'm really multiplying by a negative. And since I'm multiplying the top by this negative as well, the negatives undo each other. But up here, the negative that I used to have, because it was 1 over x, I changed into a positive when I squared it. So the negative that balanced out went away. So because I got rid of that balancing negative, I have to put a negative in front. This is only when I go to negative infinity and only when I had to square something inside the radical. So there's this extra negative, which I can explain to you further if you need help with it, but it's only when you have a negative infinity and a square root. And now we can plug in our negative infinity, which would give us 0. in the bottom and gives us 0, or infinity gives us 0 not in the bottom, but as the whole fraction, over 3 minus 0. So we get 0 over 3, which is 0. So this tells me there's a horizontal asymptote at 0. Okay, now we're going to approach positive infinity. You do the same thing you did up here, only we're not going to have this extra little negative. So you're going to have square root of 2x over x squared plus 1 over x squared all over 3x over x and minus 5 over x. And reduce, so square root 2 over x, 1 over x squared, 3, 5 over x, plug in positive infinity, so you end up getting 0 plus 0 over 3 minus 0, which is 0. So we have a horizontal asymptote at y equals 0. And that is because when we approached infinity, we ended up getting a number as an answer.